In this problem, we are given two charges, Q1 and Q2, and the separation between the two charges is 4 meter, and we have another charge Q3, which is negative charge, and we have to find out the location of charge Q3 such that the force acting on Q3 due to Q1 and Q2 is 0. So we have to locate where I need to place this charge Q3 on x-axis, where the resultant force due to Q1 and Q2 is 0. So let's talk about the case first. Here I'm just let's thinking of this position here. So once the charge Q3 are towards the left side of Q1, what will happen is look at the direction of the forces. So this force, this is a positive charge and Q3 is a negative charge. So the force on charge Q3 due to Q1 will be attractive. The charge Q1 will attract the charge Q3 towards Q1. So this is the direction of the force. F13, what F13 means? F13 means force acting on Q3 due to Q1. So that what is means here. So this F13 means the force acting on charge 3 due to charge 1. And you know this direction, the direction is towards the charge Q1 because it is attractive in nature. Similarly, the force on Q3 due to Q2 will also be attractive in nature because these two are opposite charges. So this is F23. Of course, the F23 magnitude will be smaller because it is away from the charges. So but the point here is F23 and F13 are in the same direction. As they are in the same direction, they cannot cancel out. It cannot cancel out. So what does it mean? The net force in this particular situation cannot be 0. So the charge cannot be located in this side. Okay, now let's talk about the another situation. Here I'm assuming this to be on this side here. If the charge Q3 is located on this side, then let's try to figure out all the direction of forces. The force due to this charge Q1 will be in this direction because they are attracting. This is the negative charge, so it will be in this direction. The force due to charge Q2 on Q3 will again be in the same direction because it will also try to attract each other. So again, both forces are in the same direction. As both forces are in the same direction, the resultant force cannot be 0. So this possibility is also ruled out. So there is only one possibility now, and the possibility is the charge Q3 has to be located in between here. So now let's try to draw the direction of the forces. So here, this is the charge Q3. The force onto charge Q3 due to Q1 is in this direction. It will attract. And the force on charge Q3 due to Q2 is in this direction. And these two forces are now in opposite direction. So if we select this position X, or the position of charges, then the net resultant or the resultant force on Q3 would be or could be 0. So we have to find out the location of charge Q3, where if we place Q3, the total force onto Q3 is 0. So we have assumed this distance x here. If this is x and this is 4 meter, then the distance between Q3 and Q2 will be 4 minus x. Okay, 4, this is 4 and this is x, so this distance will be 4 minus x. And now we already know the direction of q13 and q23, or f13 or f23, and these two forces must be equal in order to have the resultant force on q3 to be 0. So what does that mean? F13 must be equal to F23. And from Coulomb's law, what is the force between the two charges? It is given by K times the magnitude of Q1, magnitude of Q3 divided by the distance, and between 1 and 3 charges the distance is x, so it is x squared. The same way F23, that means the K here, K is a constant, it's a constant, okay, and this constant is the permittivity of the free space, and we already had talked about this one in the other videos. And this force is now Q2 times Q3, these are the magnitude of the charges, divided by the distance squared. The distance between these two is 4 minus x, so 4 minus x squared. So we can cancel out k and k. We can also cancel out q3 and q3. And the magnitude of q1 is 25 microcoulomb, and the magnitude of q2 is 10 microcoulomb. The microcoulomb and microcoulomb also cancels out. So we have 25 times 4 minus x squared, these two will multiply, and this side will be multiplied, 10 times x squared. And if you do the math, then you will get to this equation here. If you square and then multiply them and simplify, you will get this equation. So this is a quadratic equation. A quadratic equation has two solutions. The one solution is 2.545 meter, and the other solution is 10.88 meter. So what does it mean? The 10.88 meter, so all the distance are measured from Q1. So the 2.45 means if this is 4 meter, then it will be slightly here, exactly at this point, closer to Q2. And the 10.88 meter means this is 4 meters, so it has to be somewhere here. And we already have ruled out this possibility here. If the charge Q3 is on the right side, the net force cannot be equal to 0. Mathematically it is possible, but physically it is not possible. If this charge is here, then due to the nature of the forces, the total resultant force cannot be equal to 0 if this charge Q3 is on this side. So we have only one possibility, which is x equals to 2.45 meter. So this is how we figured it out, the where we should locate the charge Q3 so that the resultant force due to Q1 and Q2 on charge Q3 is equal to 0. So this is it from this talk here, this lecture. If you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.